Right. So now I'm recording. So please, yes, go on.
Yes. So when you're identifying positive cells in your slides, the first thing you need to do is to set the staining vectors. And what that does is that it tells the software what's positive and what's negative based on the DAB and hematoxylin thresholds. So it kind of has an algorithm inside the program that will help it identify what's a brown cell and what's a not brown cell and so on. So to do that, you press Control L, and that will open up the command list. So there you have your command list, and in this command list, you can search for many different things that you can do in QuPath. But what I want to do right now is to set the staining vectors to be able to tell the program what's positive and what's not. So then you write estimating stain vectors, press enter. Oh, yeah. And here, according to the Pete Bankhead, you just press yes. You can ignore this. Then you will get up this window. And in this window, you can tell the program essentially what's a DAB brown positively stained cell and what's a blue cell based on the oxidant staining. So when you do this, you can also press auto, and the program will by itself try to identify based on a specific area. So you first have to annotate the area. So I'm going to close this down here, and then I'm going to draw an annotation. When you draw the annotation, you want to get backgrounds. You want to include the DAB brown cells, and you want to include hematoxylin blue cells. So, for example, this is just a random area that I put together. And then I use this area to set the staining vectors. So again, Control L, estimate stain vectors, and it looks something like this. And you see that this is off right now. It shouldn't be looking like this at all. So then you can press Auto, and it will align it a lot better. Then you can move these arrows to include or exclude more cells in your identification of positive cells. Something like that, right? But that looks quite okay to me. So then after you've pressed auto, you get, so these are the parameters for hematoxylin here and DAB there and residual there. So these will then be changed. So we'll go from this to something different to this approximately. So you press OK. And then you can call it, so this is for CD8. So I'm going to call it HDAB CD8. And you see that the numbers here have changed. So what's important to do is that when you're working with different slides, so if you have slide 1, 2, 3, 4, and 5, you need to make sure that these numbers are quite similar in between those slides. So you get a homogeneous identification of your positive cells. Because if you have different numbers, the software will detect different things, and then that won't be representative. So once you've set your staining vectors, you can then identify the positive cells. So I no longer need this object. I can delete it. And then I go back to my command list, Control L, and I write positive cell, and you get positive cell detection over there. So this is the command that you'll need. Then you can open it. And then here are the parameters that you need to play around with. Again, according to Pete Bankhead's tutorial, these are all quite good. But for example, you can identify cells based on the hematoxylin and hematoxylin staining, so based on the blue cells, or you can look at optical density. I'm going to see if I can demonstrate that somehow. Yeah. So if you use this, then the software will identify the cells based on the blue nucleus, right? But sometimes, for some tissues, that might not be the most optimal thing. Sometimes you might want to use this instead, and then it'll identify it on the density of light that comes from the different images. So I think what you'll have to do is play around with these two parameters and see what works best in your analysis. For me, for a tissue like this, the what's it called again? The optical density would be very well, would work very well. The problem is in other tissues. I'm going to see if I can find them. Just 1 second. Basically, tissues with artifact areas that are a bit trickier to analyze. So, like, let's say, yeah, maybe something like this. Maybe something like this, where you essentially have a bunch of gray spots that might give off an optical density, but they're not actually cells. So if you use that other optical density way of measuring it, it will identify these spots as cells when they're not actually cells. So the benefit of using the hematoxylin one is that it won't do that. but I think you just have to play around with it for a bit. So let's assume that we were to keep this at using the hematoxylin one. The pixel size, I usually just keep it static. I don't really change it, but you can play around with it. And if you do play around with it, basically what will happen is that I think if you make it very small, it can take quite a long time for it to process the analysis, right? And to be honest, when I've tried to play around with this parameter, it doesn't make a very big difference if you make it a lot smaller. It won't improve your results by a lot. If you make it bigger, on the other hand, it could potentially affect the results, and I don't think you need to necessarily change this parameter here. The background radius I also kept static. I didn't move around. However, the median filter radius and the sigma, those two you have to play around with because basically these parameters are used to identify the fragmentation of the cells. So if you, for example, run your analysis and you see that two cells that are actually separate, you see them as separate cells, but in your analysis they're measured as one cell, so only one cell is positively detected. That means that there's something wrong with these parameters. And again, it will never be perfect because when you play around with them, you can maybe separate the cells, but then what you're also doing is that you find one cell that it isn't supposed to be separated, and then you'll separate it. But again, you just kind of play around with parameters and try to make it work. So it's both median filter radius and sigma. Um, these two parameters, obviously, you tell the system what's the minimum area of a cell that you identify and what's the maximum area. So if you look at your analysis and you see that there are cells here that the pipeline isn't picking up, then you might need to change these parameters. And when it comes to the threshold here is referring to the hematoxylin. So, for example, if you see cells that are lightly blue in your stain, but they're not being identified, you might have to reduce this threshold. And if I remember correctly, this was something quite similar. So I remember the ones that I used were something like this. Oh, sorry. And that's only because when I was running my analysis, I noticed that it was missing quite a lot of cells. But again, the lower you go on this, the higher the risk that you also pick up things that are not cells, right? So things that are very lightly stained will be identified as positive, even though you see visually that it's not a cell. So I would try to bring this down as much as possible, but at the same time, it's important that you're not picking up things that are not supposed to be picked up. The cell expansion, I didn't really play around with it a lot. I can show you what it means in a second. But the important one here is the intensity threshold parameters, because I'm not sure exactly what you're looking at your analysis. But for me, I just wanted to see if a cell was positive or if it wasn't positive. I wasn't looking at the intensity, the percentage of the intensity. So I wasn't looking at weakly stained, moderately stained, or strongly stained. I was only looking at is it stained or is it not? Is it positive or is it not, right? So depending on what you want to do, you'll have to decide if you're looking at a single threshold, so that's positive versus negative, or if you're looking at different thresholds. And then you have to define what the different thresholds are. So again, similar to the hematoxylin thresholds here, this threshold is for DAB. So it's for the brown stain that you see in your picture. You try to bring this down as much as possible, but also to the point where you're not identifying things that are not supposed to be identified. So for example, for my analysis, I was trying 0.1 and that appeared to work. But I remember when I showed some of my stains to Dana, for example, the monocytes, which were CD14 positive, it was missing a lot of those cells. So I had to bring it down even further. So I would try to maybe bring it down to then 0.6, 0.06. And then when you do that, you again have to make sure that is it then picking up things that are not supposed to pick up. So you try to bring it down as much as possible while also not picking up random things that are not supposed to be picked up. So this is just all of the different parameters. So then if I go back to my objects, let's say I'm looking at the epithelial compartments, and I am okay with all these numbers. So let's say I was using something like this. And here you could use either the nucleus or the cell, what's it called again? Stains. I think Bankhead, when he was giving his tutorial, recommended that you use this one, just because it would pick up more things. So that's what I was using for mine. But again, you can try both of these and see how well it performs for your pipeline, for your analysis. So I use this one. And then you can click on the compartments. If I remember correctly, I did something like this. And then you run the analysis. Yeah. Okay. So then you can look at it basically with and without the staining.
Wow.
And then you decide how happy you are with the cells that it has identified, right? And then, for example, let's say this one here. This appears to be, sorry, this one here. This appears to be brown, but it's not being picked up. So then you can ask the question, why isn't it being picked up? So it identifies uh, it's identifying the DAB staining, right? Which you see there. But if you click on the hematoxylin staining, you see absolutely nothing. So in order to identify a positive cell based on the parameters that I've set, both the blue and brown staining need to be there. So I would, again, like Himal said, play around with these different ones to look at how happy you are with the staining as well. Right? So then you could do the same thing with the stromal compartments. And I would just run it again.
I think you picked a very difficult one with very crowded cells.
I agree.
But let's see if it differentiates the cells, because it has a problem, you see.
This is a problem,
there.
you see? For example. So then I can try to see if I can make that any better. So if you want to delete your quantification, or your positive cell detection, you can click on the object and then on delete and delete all detections. And then that will make it cleaner. Because in QuPath, if you just keep detecting, they can't stack up on top of each other, and then you won't be able to see anything. It'll just be chaotic. So I would just delete. And I think is that area. Try to see. No.
No, I think maybe the other way. Yeah.
Yeah.
And maybe the radius of the nucleus needs to.
You think this one?
I think maximum area 400 is way too big. I think 20 should be okay. And then minimum area, maybe you could put it.
Like 5 or
8 or something like that.
Okay.
1, I think is. Yeah. Okay, let's try like this.
I think it's better.
Yeah. But now it divided the cells.
You see, I think this is the problem. This is where you have to play around with it and kind of find something that works. So maybe this is too low now.
Yeah. Maybe.
Sorry, where is it divided the cell?
Let me see if I can find. Wait. Do you know the Zoom tab is blocking my 1 second.
Yeah.
My things.
Yeah, so
you can kind of do this to play around with it, right? So the question is, I guess that's okay.
I think the positive cells, the cluster down into the left and up, yeah.
I mean, this looks very strange to me. Yeah. I mean, that, for example. But again, don't I guess for you, Alan, don't let this confuse you, because this is just the radius. So the cell is actually here in the middle. But the problem is if you have this being divided in something that's supposed to be one cell, then there's something wrong with your parameters. Yeah, this wasn't a good course.
So the first one was actually better, because at one point you have to accept that the program will do some mistakes, or that it will not be 100%.
No.
So then you just have to decide.
Yeah. But yeah, you just play around with these parameters and try to make it work. Oh, yeah. Okay. But yeah, so you have this threshold. You try to keep the thresholds. Again, when you do this, look at your different cores, because you might have to play around with some of the parameters, because some of the cores, there is some differences between the cores. So what I would do, just to make it very smooth, is I would make all of my annotations And then after you've made annotations, you can select them all over here. So here I have two annotations. You can click one, shift click the other, and then just run this code, and it will run the script, or it will run this detection on everything. And then if your computer can handle it, basically when you do that, it will overload the computer and it can shut down the program. But if you can, try to do that. If not, maybe select 10 annotations and then run it, then select the next 10, run it, and so on. But yeah, after you've done your positive cell detection for all of them, then I would go inside and look at every single different core. If there's then problems, you can delete those detections and try to adjust it for that specific core, just to kind of speed things up, I guess. But just after you do that, you can then create some kind of script. So you click on workflow and you click on create script. Then you have to adjust some of these things. But for example, what I did first was to set the vector stains, and it will include that in the script. So every single thing that you do manually in QuPath will be saved here. And then you can kind of delete the rows that you don't necessarily need. So if you're just playing around trying to like figure something out, then you don't want that to be a part of your final script, right? So you would delete that sentence. So for example, here I was trying to play around. I wasn't happy with this, so I did that. I could just erase it from my script. Well, yeah. Okay. Yeah. And then if you want, you just, when you have your script, you can just save it, and then you can just run it for your entire what's it called again? For your entire slide. But again, you could do this, but what I've noticed is that there's always differences between the cores, there's differences between the slides. So for me, it's just easier to select the annotations manually and then just run the positive cell detection for all of them at once. And I think your computer will be able to handle that all better. But I think, yeah, that's what I was mainly doing to identify the positive cells.
And then
is there anything that you were saying?
Sorry, if you could show him also where then he finds the data and how to export them in an Excel.
Yep. Yes. So let's say I'm gonna wait. I'm going to delete all my detections. So I'm gonna run this positive cell detection for the epithelial compartments. And then I'll do the same for the stromal compartments. And then if I want to extract the data, you click on this icon over here, which says show measurements table. And then you can do show, I think, was it annotation measurements, I guess. No. Oh yeah. Yeah, exactly. And then you can, so these are all of your metrics. Then you can copy them to clipboard. Then if you go into Excel, say, when you press Control V, it will all be pasted in, basically.
We don't see your Excel now.
Oh, okay. 1 second. How about now?
Mm-hmm.
So everything that was in QuPath is now pasted over to Excel, and you get all of these different metrics. So the number of positive cells, the number of positive percentage of positive cells, the number of positive per millimeter square of your compartment that you annotated, and it'll also say what the different compartments are, right? So one was tumor, one was stroma. Then you can kind of create a big master file that looks something like this. Let me see if I can just find one.
Yeah, he will do just in the tumor, and he will need just the positive percentage.
Oh, okay. Then that's a lot easier. Yeah. Yeah. Let's see.
But then it's just very important to remember which annotation belongs to which core.
Yeah. Yes, good that you said that, Dana, because then I can show you something that helps with that as well.
If you could show him the trick with the small lines, that's what you want to show, like Stian did. That he linked all. So Stian was linking all the annotations of in a core, all the tumor islands. He was linking them with small lines. So then it was only one.
But you don't have to link it.
But you don't have to do that. Yeah.
No.
I think...
Okay.
No, you can just select everything and combine them up. So it's a single trick. So
you can merge them.
Like you combine the objects in PowerPoint to make a single object.
Oh, it's possible. Okay, please show us.
But I think Alan, you've been doing that, haven't you, Alan? I think because you merge your annotations, that's all you do, right?
I've merged.
So I think he knows how to do it.
Oh, okay, great.
Yeah. I mean, I guess another way. So you get, I was going to show you, you get an Excel file like this. So mine is a bit longer because I have both compartments, but you get something like this. So you just copy over everything from QuPath into Excel and it'll look like this. Well, 1 second. So, do you see my QuPath now?
Yes.
Yeah, good. So I think, Alan, like you said, you can do it the way you've done it. So you can just merge them, or if you want, you can draw an annotation, and then let's say you make it longer, but then you want to exclude a compartment. You just press Alt and you delete things in between it. So this will still be identified as one object, right?
Yeah.
So this would be count as a single. You don't have to merge it.
Exactly. So this you don't have to merge.
So you first mark the whole core and then
you erase it.
Yeah.
Or you could do it like Alan does it, and you just merge them as well. So there's different ways of doing it. But what I wanted to say is because you need to, sorry, 1 second. Yeah, because you need to know what your cores are in terms of like the patient block numbers. So the block numbers, what I would do is after you've made all of your annotations, I would then give them the same name as the core in your master file. As for example, I would click on set class, or sorry. Oh, and which one was it? Oh, annotations, set properties. And then here, let's say your block number is B11364, whatever. Then you have that on your annotation now, right? So when you then transfer your data to your Excel file, this information will be carried there as well. So then you can very easily connect your Excel file, so your master file, with the data that you get from QuPath. So I would therefore just give all of your annotations their respective block numbers.
Yeah.
Aline, I will send to you the Excel tables with the patient number and which cores are on the 4 TMAs, the 4 slides that you have, because I have that.
Yeah, that would be useful. Thank you.